because he is in my student to attain a high level. Once again, I welcome you, sir. Thank you.
Thank you, Gopi sir, for such a warm and kind welcoming. I'm very glad to be here and I'm very honored to share my experience, what I go through in my past, my career. So I'm such a happy to see you all again. Thanks.
Thanks, sir.
Can I proceed, ma'am? Can I share my screen? Shall we start?
Yeah, you start presenting your PPT slides.
Yes. I have shared my screen. I hope you guys are able to see my screen. Is it visible now?
No, Prakash
Not
sir,
it is.
it's not visible.
Not it is.
Okay. How about now?
Yeah, it's okay, fine. Yeah.
Okay. So I think I have my slide number 1, right?
Yes, visible.
Yes. So first, I want to say a very big thank you to give this opportunity to my beloved college. So where I have studied there. So I've been very honored to present my knowledge or in what is my career, what I have done in my past life. So I'm first very thanks to all and thanks for your time to attend this FDP program. So myself, Prakash Francis. So who am I? So what I did for my past experience. So I'm a student of AVC College of Engineering from the Department of ICE. I passed out my college in 2012 from the ICE department. There I have learned my engineering. What is instrumentation? How the engineering, how it can work, how we can the world it's running on the engineering. So everything I have grabbed from my the college, and I have moved into the Chennai. So basically, I have worked in some small startups in Chennai and Bangalore. So those were very initial days, 2019, 2013, and 15. So I have worked in a couple of startup companies like Elnix Technologies and Micrologist Systems. Later, I have moved in the L&T Technologies Mysore. There, I have experienced what is the corporate world. It is actually working on automotive. Okay, how the industry, the corporate industry, which is involving in the, especially on the automotive industry, we have a lot of domains. We can work in the semiconductor, medical, aerospace, different kind of domains. So, what is my passion? So, I am an automotive enthusiast. So there I can started my career in L&T Technologies. Later I have moved in the Harman connectors. Are you know very well about the Harmans. So it's they are very good in the sound and infotainment system in a car and the audio system like a JBL, Philip. Lot of audio system they have worked in the Harman. Later, I have worked in the actual India's #1 the car manufacturer, this Maruti Suzuki. There, I have involved in the testing of the cars like Vitara Brezza, the Shift, the actual car domain I have validate there. Currently, I'm in Bangalore. I'm working for Ola Electric. So as we know, the electric vehicles are in future. So we are preparing ourselves to getting ready to commute ourselves in electric domain. So and also I have various testing knowledge in the hardware in loop and software in loop, and later we will come to what is hardware, what is software in loop. We will in the upcoming slides. So this is some short intro about me, and I will proceed with the presentations. Okay, so here now I am going to present 4.0. What is 4.0, industry 4.0? How it is affecting, or what are the effects it given in the automotive industries. So I have just categorized this session in 4 topics. So first sessions you will get what is 4.0, and the second one is how the 4.0 is implemented on the automotive sector. So we have a lot of technologies. We have some fair enough idea from the past previous sessions, some last couple of weeks. Sorry, from the last weeks. So how it is affect those technologies affected or make changes in the automotive field. And the third one is what are the real-time application actually we are using in automotive, and what are the real-time challenges, and what are the usages, advantages of the 4.0 in actual scenario. We will discuss. We're going to discuss about that. And the fourth one is for the faculty and the research scholars, the students. So I believe this is the most important one. So what are the tools, the software tools we can able to learn, and we can shape our career in automotive industries. So there are a lot of softwares we can able to learn this for electrical engineer, electronics engineer, or instrumentation engineer, whoever, computer science. So what are the tools we can actually learn, and we can shape our career this. Right. So this is a very basic timeline of 4.0 industry. So this you might see this slide from different theme or colors from the previous sessions. So let me just give some small intro about the revolution on industries from the 18th century, where we started, not from the Ice Age or the Stone Age. So just very recently, from the 18th century until now. So we can categorize the industry revolution in 4 manner. The first industrial revolution started on the 18th century. So we know at the time we have a lot of usage of coals. So we need energy from the coals, and coal we are burning, and we are making the steam engines, and we are using for the commute purpose. We are using the steam engine trains and all. So later, once the electricity is invented at the mid of 18th century, so the electricity lightened up the world. So everywhere electricity, the people knows what is electricity, what is the power of electricity. So different products, different system, the technologies have been lightened up in the second industrial revolution. This is the major turnover of our industry platforms. So after that, a lot of electricity based mass production happened. A lot of very big industries are stepping into the world. Yes. And this third industrial revolution, I can say it started on the very early of 20th century. So once the computer is invented in the 1970s, so people know about the semiconductors, the usage of the semiconductors, what about the chips, and they can use a lot of, there we are just entering into the digital world. So whatever the systems, number systems, everything we are converting to as digital. So here, here we are entering into the software domain. So actual, it started from reducing the manpower, all computer-based tools, the machines, everywhere it started involving on our third industrial revolutions. And the fourth industrial revolutions, actually we are experiencing now. This is the major important major one in the industrial revolution. So what is industrial revolution 4 it means? So basically this is the AI based one, artificial intelligence based, the big data. So all this big based on the data analytics. So every tools, every machines, every factory, every technology has the data and has the connectivity between the different technologies. So now we are experienced, or we are the evidence for this fourth industrial revolutions. Yes. So what is 5.0? What will be happen? Yeah, we will definitely, we are going to experience this in after 10 or 15 years. It will be a complete electric related one, I guess. This, we'll move on to the next one. Okay. So what are the technologies we are using in the industry 4.0? So you already I mentioned you have fair enough idea from the previous sessions. So most of the speakers, they might explain in their own way what are the technologies they have used for their domain. So I have just listed out what are the some major components in industry 4.0. The first one I can say the big data and data analysis. So here what we are doing in big data and analytics, how it is helping in our actual market and present systems. So 10 years back we don't have any e-commerce platform like Amazon, Flipkart. So we have to go to this shop and we have to buy our own self all the products and everything. So once the AI introduced in the into the market, so it gives the wonderful technology or wonderful platform, all the internet based shopping, like as I said, Flipkart and Amazon. So there the big data, the data science is involving in the e-commerce platform and the space research, automotive industry, everywhere. Basically it collects all the data of the existing technology and how we can combine or how we can modify the existing technology, how we can create the new one. So everything is data now. Without data we can't create any new product or new technology, whatever. So the data is a mandatory. So the group of data, the bulk of billions of data helps to improve our technology and our lifestyle. Yes. So the next one is the very important, and it's not very familiar now, but I'm sure it will. This augmented reality, it is going to be a very big boom in the future days. I will explain how the augmented reality technology, it will affect our future, what we will face and what we will experience in our future lifetime. Yeah. And the third one is the IoT, the cloud based. So everyone has the smartphone, the data, the clouds, everyone aware of the internet. So all the data, all the connectivity, we are using the internet to collect the, if we want to search some, if we want to study something, all it is from our cloud servers. For example, the being Microsoft and the Google, as you know, you already experienced this. And here, and the next one is I'm moving the autonomous robots. Here I'm meaning the robots means I want to specific the robots. It's a car. I'm talking about the car in autonomous robots. How the industry 4.0 it's changed in the autonomous vehicles, right? And the next one is the smart factories. So here the smart factories, we have the normal industry. What is the difference between the normal one and the smart factories? How it is differentiate? How we can move up on how we can improve our production? Lot of automated systems and everything. It's in the smart factories, right? So in the 4.0 technology, I just picked 3 of technologies where the it's implemented in automotive sector. Okay, so I can say there are three major role. This is the future technology, and it just started. It's the baby step in the automotive technology in Indian market or European or the worldwide automotive products. So the very first one is the ADAS. What is ADAS? Now we are the most of the people knows how to drive the car, right? So without a driver, without any human intervention, we can able to come at one place to another place. So this feature we have already experienced in the Europe side and the US market and the US roads. We have experienced this, but it's on we are in the Indian market. We are just baby stepping in the ADAS segment. Very few car OEMs have started manufacturing this ADAS now, but I'm sure later most of the OEMs will analyze the Indian roads conditions and how we can make the ADAS car in Indian market. This okay, and the next one, the smart factory. Okay, so here how the Industry 4.0 principles and their ideas, their approach, how important to build a factory. We are going to talk about this in the next slides. And this augmented reality. Here, this augmented reality, how it is involving in the automotive sector. For example, if I want to design a car, so we have some software, CAD, CATIA, other software tools we are design a car. So this system, the augmented reality, the VR system, completely going to change the vehicle designing platform, how it can be designed. So we will experience in our naked eye. Okay, we can realize, we can visualize our design. Okay, what are the systems we can visualize the functionality. So it will reduce the time, and this technology gives a lot of creativity in the automotive, especially in the car or two-wheeler manufacturing. This. So these three areas I'm going to focus on more about this. Yes, the very first one. So augmented reality. So reality, what is augmented reality? This technology is a VR. So we have played some games, the VR-based games. We'll have some goggles and we will wear it, the wearable technology, right? So we can wear and we can visualize our entire environment. So this technology, I can show you some example. So how we can design our car in future, and what are the designs, and what are the entire chassis platform and the door system, all the entire car you can able to visualize, and we can change. Okay, keep this this unit, the wiper unit, all the models can easily visualize, and we can change our design. So it will give a very smooth and very it's up to our imaginary. So wherever you want to place this, so the creativity, it will be increased, the design approach, and everything, it will change in our this design approach. So this augmented reality helps the developers or the designers who are the car or two-wheeler designers. It will actually reduce the cost and the timing. This is the most important feature of this. Okay, for example, if I want some prototypes, okay, I'm going to release some car in next year. So in my factory or my team, I have group of developers. They will work on the design. Okay, what are the colors and how the chassis, how the dynamic, aerodynamic, all the specification we have to work on it, and we are able to making the 2D drawings and other things. This technology actually helps the completely to what are the new features. For example, in a car nowadays we can see the head-up transparent HUD display, right? The highly transparent transparent display. It will the instrument clusters, the infotainment systems, everything. So we can visualize the entire car atmosphere or the two-wheeler atmosphere. How many seat, how the seat positions will be, how many the load, how much it can be driven, and everything we can visually we can create and we can implement into this feature. So this designing approach is going to rule in few years. So this is the most interesting topic in 4.0. Thanks to this approach. Yes. Next, I am moving to the ADAS car. So what is ADAS? So automated driver assistance systems. So this is the car image I just picked from. This is an upcoming car from the Ola. So you might seen in 2024 or 2025. This is the car ADAS, completely autonomous driven car. You can see in our Indian roads. This. Okay, before we look into we have to what is ADAS and what is the history of ADAS, where it is started. So we have to go back from 50 years back, where it started, the commute system, the transportation system, where it is begins. So in early 1940s, the car OEMs are introduced. This is the most first technology, the ECU, the electronics based technology they have into the cruise control. If you know, I think what is meant by the cruise control. This. So the very first software feature they introduced is the cruise control. In 1990s, we have created very short range communication. This is very radar based and the spectrum based. In all the cars has communicates with the short range radars. We have tested short range based communication based on the autonomous cars. So later, when I was the engineering, I just saw on YouTube ad, the Google is going to introduce some self-driven vehicle like a bicycle. So at the time we are very curious about how it will going to work, how the cycle or the vehicle is going without a human interface, how it will work. We are so excited, but now we are experienced that. So Google in 2009 it is introduced the self-driven car. So later, once this Android development, once the smartphones occupied the world, so we had a lot of technology and the customized the OS and the mobile platform and everything. So it's occupied the automotive domain also. So the major turnover is the Tesla. The Tesla brings it gives a major breakthrough in autonomous vehicle. So the Tesla given their own electric vehicle and the fully automated electric vehicle they have introduced in the 2015. That is the main changeover of in automotive field. Later, every OEMs they have started. Okay, it's the proven. Tesla has proven this technology. Okay, all the future commute will be in the electric based and the autonomous based only. Why the autonomy is so important? Because we are every day we are experiencing the traffic, the lot of accidents, and the human error. So many accidents are happening. To avoid that, how this autopilot system in a car, so how it can be help us to reach zero accident or zero death, the human death. So I can say that Tesla brings the change the entire world transportation systems. And this is in the recent before COVID, a lot of OEMs had started their own factory setup in autonomous vehicle. Most of the vehicles they have right now it not hit the Indian market, but it is in the US or European markets. It's already, we have the luxury cars that are fully function, fully automated autonomous vehicles. It may take some time to hit this Indian market. We will maybe by 2025 or 2026 we will get this cars complete autonomous. Now we have semi-automated one, right? Yes. So what are the technologies ADAS has? Okay, how the ADAS is working. So this slides is giving some overview of this the autonomous car system. Okay, what is the car contains? What are the networks? What are the components we have? So basically, if we take the car, we have in a normal, the IC engine cars, we'll have the steering system, the infotainment system, the engine, and the fuel control, fuel injections, and that fastening position. These are all the normal car components. But in ADAS, how the ADAS is working, and what are the major components here? So the very first one is the radar. And the second one is LiDAR and the GNSS. The GNSS is for the GPS positioning sensor, and the camera and the V2X. So V2X is vehicle to anything or everything. Okay, and I will explain one by one what is radar, what is LiDAR, and what is GNSS is doing. So first I will talk about the radars. So in every car, we will have the radar component. We have three types of radars: short range, mid range, and long range. So based on the distance, so it will detect the objects. For example, in a car bumper on the front side, we will keep the radar and the side view and the back view. So is any nearing objects or moving objects, it will detect the objects and it will send the signal to my controller. So the car has the multiple ECUs. The master ECU, it will receive the radar signal. Okay, some objects are nearby the car. Okay, what we have to slow down or we have to park. So what action to be taken? So the central CPU, the central processing will take care of. This is a master ECU in the car. So it will receive the data from the radar. It will act like this. So we are going in 60 kilometer per speed. So we are seeing some signboard. Okay, we are entering into the city limit. Reduce the speed. It's reached the 30 kilometer the speed signboard. So automatically it brings down the vehicle in 30 kilometer per hour. So it will recognize what is signboard, what is speed breaker, is any human is there. So it is detecting all the objects and it will send the signal to the CPU, the central processing unit. This is the major role of radar in autonomous vehicles. The next one is LiDAR. So LiDAR, light detection and range. So this LiDAR operations is to emit the pulsars. It emits and reflecting to the object, and it will create the 3D models or the 3D scenario, 3D environment. So the central process, the CPU, will recognize what is the object and how the pattern. So whether it's a car, it can able to differentiate this, mapping the 3D environment. This. And the GNSS is for it's fetching the data. It's a positioning sensor, the GPS sensor, where is the car is actually, how long it take the reach the destination, how fast we can go. So it will get the latitude longitude data from this. It will receive that data from the satellite. We have a lot of intermediate apps to receive the data, the positioning sensor. It will feed the data to the CPU. According to that, the vehicle will react this. Okay. The next one is the high-speed camera. Okay, the camera, it will receive or record the video or image of this. Okay, what is it's like our naked eyes. Okay, what I'm seeing this. So where I am, which which road or what is the environment. It's the camera, it's capture the environment and send, okay, which landscape I am. For example, I want to go in a multiple 8 ways lane system. So which lane I have to maintain? What are the lane detection systems? So which lane I have to maintain? So all the information it will identify from the roads and it will send the data to the central processing unit. And the next one is the power supply management. So every vehicle has a different kind of, in a vehicle we have the 8 volt and 5 volt. 5 volt is for internal vehicle networks. So major how this components are talking each other based on the CAN network. Okay, so how many nodes in a car? So it's very important how the handshaking is happening between those ECU, how the data exchange is happening. For example, if I'm going to hit on any of the object, so now the airbag has to release. So how the object from the central CPU to receive the, okay, this is the vehicle is got hit, release the airbag system. So this hand message protocol, this handshaking protocol needs some power supply and CAN bus, LIN bus, flex ray. We have a lot of communication protocols in vehicle. So it has the unique power supply. For example, CAN we need a 5 volts, LIN other power supply for interiors like indicators, the tail lamps. So all the power management can taken by the power ECUs. And what is V2X? V2X means vehicle to vehicle or vehicle to anywhere. So for example, if the two vehicles are two ADAS based, autonomous vehicles are driving, all the vehicles are ADAS based, means suppose if ambulance is coming in 2-3 kilometers away, so that ambulance data, it is transferred to it will receive by my car. Okay, the ambulance is coming some 2-3 kilometers far away, so I have to make a way for this. So the data exchange between the vehicles, how far it is, what object is coming, and also if any signals is again for a red, any signal is going turning the green, okay, I have to achieve the signal within 1 minute or 2 minutes. So all this data exchange between my car and other vehicles and other scenario, other environment like a traffic system, everything. So this is the major technologies involved in the ADAS car. So it helps to make the self-driven. This. Okay, so the self-driven cars categorized according to the SAE. So what is SAE is Society of Automotive Engineers. We have some community. So the gang of automotive engineers, they are categorized what are the levels in ADAS. Okay, the 11.0, I can say there is no zero, there is no automation. This is completely a driver dependent. 1 to 5. So 5 is the fully automated one. Okay, so here in India, most of the OEMs are they're making 0 to 3rd, the conditional automation, level 0 to level 3rd cars are in. Right now we are using that. So this level 4 and level 5 is are the future, the complete automation, but the vehicle is controlled by the driver. It's we can, if we want to take it, or we can, otherwise we can make it in the autopilot. Okay, the level 0 is there is no automation, only the completely driver dependency. The 11.1 is the driver assistance. It means vehicle has some feature, but it's completely controlled by the drivers. And this level 2, it's a partial automation. Vehicle has the automated functions like power steering, so how to turn. All this is controlled by the software, the ECU, but over the it's act as like a slave devices. So driver is the master, so it has the software controlled by the software. This second one is the partial automation. So third level of this automation is conditional automation. Driver is a necessity but is not required to monitor the environment. So right now we are seeing the Mahindra XUV700. So this is the best example for the conditional automation. So in XUV700 we are going for, if we are going in the highways, okay, the road is straight or for a long, for a straight drive. So we can use the driver, just they will keep it in the autopilot, and it's, but full control it's by the driver, but the vehicle has itself, it can take some decisions. Okay, the speed breaker is coming, the people are moving. So these are all under come level 3 conditional automation. High automation and fully automation is completely the driver has, whenever the driver wants, they can do. Otherwise, it's all the decision making of the drive. It's entirely depend on the vehicles. So all the how fast I have to go, what is the fuel economy, at which gear I have to move, everything it's taken care by the car itself. The driver, just if any emergency, the time the driver can use this. This is the level of automations. The SAE categorizes this level 0 to level 5. Yeah, okay. As I mentioned earlier, this is the basic ecosystem of the car. So where is the radar is positioned, where is the cameras, where is the lidar. So this in the top, this is for some for the R&D purpose. At what height we have to, how we can gather the data or read the environment. The radars is placed in front of the vehicle and the side waves, because in the back side of the vehicle. So because it will continuously emitting the signals. Any object is nearby my car, it is going to hit, or it's making a way. All the data from the radar, it is go to the CPU. The ECU will take care of the control this. Okay, this wheel odometry. Suppose this is the one important feature in ADAS car. So the TPMS, the tire pressure monitoring system. Nowadays, a lot of cars has implemented this function. So if you're driving for a very long time, long ride, if you're going, so your tire pressure, it might go low. So it will always monitor your tire pressures. Okay, suppose one wheel is getting the pressure is going, it will we will get a notification in the instrument cluster or in the infotainment systems, and it will calculate, it will send the how fast vehicle speed. We have the speed sensor here. It will give the how fast we have to go. Is any objects find, we have to immediately reduce the speed. Okay, it will get the feedback from the wheel odometer system, and the ECU will calculate and it slow down the vehicles. Okay, the cameras and the lidar, it's for capturing the environment and make a 3 algorithm to execute the algorithm for a self-driven this. Yes. So as we discussed, these are major key components of the ADAS vehicles. The first one is the sensor, which software, because it has the hundreds of ECU in a vehicle. ECU for a wiper, door, and the fastening system, and the instrument clusters. Each ECUs will talk to the master ECU. It will transfer the data. In very high speed data transfer will happen. So the software, it helps to make a CAN communication protocols or LIN based or FlexRay based data communications. This. and more important is the processor. Okay, so which processor? In ECU we have a very high speed, high performance processor, because the processor execution time, it should be in a very nanoseconds. Suppose we are get hit by any object, the airbag has to release within a nanoseconds. So how we can implement this with a very high speed processor? We are using the Intel or AMD processor inside. Very high processing, it will high RAM, high performance based processor or used in the ADAS platforms cause. Yes. Yes. So this is some overview of the what are the companies they are making the ADAS, involving the ADAS cars. This is majorly in the Europe and US side. The Audi, the Porsche, Toyota, Nissan, major is Tesla, the BMW. So these are all the premium cars. They are they introduced their ADAS vehicles in Europe and the US as well. And in India also, this Tata and Mahindra and major OEMs, they are trying to develop their fully automated vehicles, and it will hit the roads in another some 4-5 years, fully automated, because it's completely depend on the Indian roads. We have to analyze the Indian road. Depend on that, we have to make a lot of algorithms. We know very well how the road systems in Europe and the US. So it will take some time to hit the Indian roads for us. Yes. Yeah, this is in ADAS. Everywhere the technology is involving, wherever the technology is involving, the same way we have some bad scenarios or disadvantages of some security threat. Some negative roles also is happening. So as we have to understand, this is very important to us. What are the disadvantages of this cyber security or ADAS thing? So it's better to know to our knowledge. Okay, what we can happen, how the cyber security is involving in ADAS technologies or other cars. For example, in the car has a multiple ECUs, like I said, airbag ECU, engine transmission controller, the steering brake, vehicle access system ECU, lighting controls, ADAS system, TPMS, key. It has hundreds of ECU inside in the car. Through that, any hackers or the thieves can easily access your car, and they can easily access the car via any browser, or any, they will send any trojans and or viruses. They can send and they can completely hacking your the vehicles. We might experience this in some in the movies as well. So these threats are very vulnerable, and so we have to aware of this. So how we can, the R&D is going on, how we can avoid this kind of cyber security threats, and how it can be controllable, how safely we can manufacture the car, how we can defend from the hackers. So these are the major areas that it helps through that the hackers will hack our car completely. This is the one major incident. It's happened. This is a real time. It's happened in real time. So the hackers, they send the Trojan and the viruses to hijack the Jeep. Okay, they are sending the user. They will, if the user is because nowadays the mobile and the car has the connectivity. So the hackers send the data or the virus or any link to their the users. It will hack by the hackers, and they have take control of it because it's autonomous vehicle, so they have driven and they have parked in the highway. So the GPS hacked in 2015. So later the world realized, okay, we have this kind of disorder, how we can overcome this security threats. Even recently, some 2 years back, they have hacked the Tesla as well through the Google Chrome browser. So they have accessed their ECU, they have opened up the doors. So this cyber security threats are more headache to the OEMs, how we can make the cars very safely. The one. Okay, so this is the one important technology. It is the upcoming technology, and we have used some OEMs are using this technology for their software updates. For example, MG Morrison Garage, the Tata, and other BMW, Audi also they are giving their software update, the vehicle software updates through the air. So OTA means over the air update. So the vehicle has their customized OS. For example, like a Move OS, every like a mobile have the individual OS, like a iPhone, iOS, Android OS, BlackBerry OS. So same manner, every OEM they'll have their own customized OS. So they can update the OS feature, the infotainment feature.